Okay, so now you're going to learn how to typeset worksheets, and for that we are going to revisit computing the dot product of x and y, and you've opened up this template in your favorite LaTeX tool. And let's see here, what do we have? Well, there's a couple of things to pay attention to. I like to define commands that help me typeset things. And therefore, there's the file here called FLaTeX, in which I've defined a whole bunch of commands that help me conveniently typeset things. One of the commands that is defined there is reset steps. What that does is it creates a blank worksheet so that when you execute the command FLA worksheet, it conveniently typesets a worksheet with whatever entries have been defined. And how to do that we will learn in just a second. Now there's a bunch more below here that you will get to enjoy later in this video. Okay, so what do we do? Well, we go to the Spark web page, to which you have been given a link. And on the left is a menu you are going to fill out. And on the right, we will generate a whole bunch of commands that will then help us fill out the worksheet. And how do we do this? Well, we go ahead and we say, let's call the function sapdot, scalar alpha plus dot product. What a blocked algorithm is, you'll learn in week 5. So let's ignore that. This is variant number 1 that came from loop invariant number 1. And notice that there are 3 operands. And notice that on the right, a bunch of stuff starts appearing, and what you actually see there is a skeleton for a MATLAB implementation of the algorithm. So what we want to do here is pick as output language FLaTeX-worksheet. And then on the right you see a whole bunch of LaTeX commands being defined, and you will recognize things like step 1a precondition, step 1b postcondition, etc. And that's all being filled in automatically. Now, there are 3 operands when you do a dot product. It's vector x. So you have to indicate that x is a vector through which we're going to march from top to bottom. That's the T arrow B. And x is only an input. We're not going to change its values. Similarly, we have a vector y. That is also a vector that we are going to march through from top to bottom, and it similarly is just an input. And then finally we have a scalar a, so we'll take a for alpha. It's a scalar, we don't march through scalars, and it's both input and output because we are going to update it. And what you see now on the right are all of these commands that are being defined. So you go there, you highlight it, you copy it, and you take that to your favorite LaTeX environment. Now before we do anything, let's actually save this in a new file. So I'll say save as, and I'll rename this my _ws for worksheet. And I happen to have one there already, so I'll replace it. And what you notice now is that partially into this document it says insert output from Spark web page below. So that's where you go and click, and then you paste. Okay, now it's always good to then go and see what this looks like. Up here is the build and view button that I'm going to push that executes a process that now typesets things on the right. And notice that on the right now we have an outline for our derivation. What do we recognize? We can recognize the precondition, the postcondition. The Spark web page took a guess at how we are going to march through x and y. We set from top to bottom, so it actually inserted an initialization step, a loop guard, and the what we call the partition, repartition, and move on steps, 5a and 5b. And from the worksheet that you filled out by hand, you find out that this was a pretty good guess, but obviously you would want to go and double check this. And now what we do is we start changing things. So if you look at what was just put into this file, you notice that it inserted the precondition, it inserted the postcondition. And notice that the steps here are in order in which you should be filling out your worksheet. So what we're going to do is we're going to change the postcondition, because obviously the Spark web page can't read your mind, so it takes a stab at what you might want to have there, and then you go and you fix it, and you say alpha is equal to x transpose y, that's the dot product of x plus y, plus y hat, that's the hat that we want to put on top of alpha. And every time you make a small change like that, you really should run this through LaTeX again. You should build it again, because it's very easy to introduce a small error, and it's very hard to track that down, especially when you use commands as extensively as I do. So you press the button, it now retypesets, and if you now focus on the post condition, it looks a whole lot better. Let's actually make this just a little bit bigger so we can see it better. All right, so you've done your first change to this worksheet. Then what do we do? Well, we say step 1, step 2 is to insert an invariant. How did we come up with an invariant? Well, we actually got it from the post condition, so we can even go and cut and paste this into the spot right here, and then recognize that all we need to do is x bottom dot product with y bottom. And now we've run this through, and what you find is that the loop invariant has been inserted in the various places. Oh, wait a minute, this was for invariant number 1, so I really should make this x top, y top. And there we have it. Okay, so what's next? Well, we move down and we say we need to come up with the loop guard. And how do we come up with the loop guard? We look at the bottom here and we figure out what the loop guard should be. But in this case, we only need to check whether it's the correct loop guard, because after all, the Spark web page went ahead and did a guess at this. And all we need to do is check whether it's correct, and it happens to be correct. So we move on to the initialization step. And we go back to the top, and we notice that indeed x is being partitioned into a top part and a bottom part, and y is being partitioned into a top part and a bottom part, and we want to go from the first element to the last element, and therefore this is being partitioned in exactly the way we want it. Good. So the initialization was done correctly by the Spark web page. We move on. What's step 5? Step 5 is to say, okay, we need to repartition x and y to expose that element. If you look on the right here, you notice that it does exactly what we hope to do, namely it partitions off the top element of the bottom part, both for x and y. That's exactly what we want. So we're in good shape. We move on. The corresponding part at the bottom shows that the element that was exposed was now added to the top parts, which indeed is what we want, so we're good there too. Move on. Look at step 6. What is step 6? Well, there we need to insert what the state is before the update. In other words, what the state is in terms of these different pieces that have been exposed. That was very much like the splitting of the range in the quantifier. So what we can do is we can go back to the loop invariant. We can take it, we can copy it, we can take it down to the step 6, we can insert it, and then all we need to do is say, oh, but x top and y top have been relabeled x0, y0, and we're good. So we build, and now we've got a problem. All kinds of errors appear here. This is why I want you to keep rebuilding every time you make a small change. And the problem here is that I wasn't very consistent in defining my commands, and sometimes it's assumed that you're already in math mode and sometimes you are not, and therefore I have to put $signs around this expression right here. And now I run it through again and everything is good. So then I take that and say, oh, next I need to determine step 7, which is the state after the update, and often that's just a small change from the state before, so you might want to go and cut and paste that, move it in here, and then say, oh, if I look at the worksheet that I worked out by hand, all I need to do is insert chi1 times psi1. And now I've done step 7. And then finally, we compare step 6 to step 7. We notice that all we need to do is add chi1 times psi1 to alpha. So in our update right here, we delete what it says you should delete, and you insert instead that alpha becomes chi1 times psi1 plus alpha, and now you have typeset the entire worksheet. Now, what's kind of cool about what we've done is that below this we have a whole bunch more worksheets, which you can recognize as step 0, step 1, step 2, etc. And what does that do? Well, if you click on this green button up here, you step from one page to the next. And what you notice here is that step 0 is the empty worksheet, and then it fills in step 1. After all, we want to emphasize the order in which we fill out the worksheet. And then step 2, step 3, step 4, step 5, step 6, step 7, finally the update step. Then we can take away all of the assertions, and then we're left with the algorithm. And finally, we can take away the entire worksheet, and we end up with the algorithm nicely typeset. Okay? So, what I want you to do next is to do exactly the same thing for variant number 2.